Okay, we're going to go ahead and do something new today. Now, all the numbers you've been exposed to up to this point are called the real numbers. They include like 0, 1, 2, 3, 4, and the negative versions of -1, -2, -3. But real numbers also include all the fractions and all the decimals that cannot be written as fractions, or like pi and the square root of 2, square root of 3 that don't work out to be nice neat numbers. We're going to expand it into the idea of complex numbers. Now, complex numbers have an I in them, and we're going to look at the square root of -1. The square root of -1 is I. That's a definition. That's what it's defined to be. So a complex number is any number that has an I in it. Now, complex number is made up of two parts, a part that doesn't have an I, and then a part that's in front of the I's. And so that part that's in front of the I is called an imaginary number. Now, it does have meaning, does have application to stuff. It's got a bad name, so don't get hung up on imaginary. But the imaginary part's just the part that's in front of the I, where the part that doesn't have I's, this 5, is the the real number part. Now, most complex numbers are in the form of a real number plus something that has I's, or a real number minus something that has I's. And then remember from what we did before, when you have two things added or subtracted and you switch the sign in between, they're called conjugates. Now, as we look down below here, we're going to look at powers of I. It does come into play and is helpful. Now, remember I is the square root of -1, but then we're squaring it. Now, remember, squaring undoes your square root, so it really leaves you with just -1. And so I squared ends up being -1. Now, I cubed is really an I squared times another I. Remember, we just mentioned that I squared is -1, so we get a -1 times I, or we get just -I. Now, I to the fourth would be an I squared times another I squared, which would be a -1 times a second -1, which would be a negative times a negative, or +1. So now, once we get down here, we would then have an I to the fourth times an I, which I to the fourth is 1, and 1 times anything doesn't change it. Or down below, an I to the fourth times an I to the fourth times another I, because you'd have to add your exponents, and 4 plus your 1 would be your 9. Well, I to the fourth is 1 times another 1 times an I, which is another I. So in other words, if your exponent here is 1 more than a multiple of 4, it's always going to end up being I. If we look at the next column, this would be an I to the fourth times an I squared. Remember, I to the fourth is 1, so we get I squared, which we know from above is just -1. Or an I to the 10th would be an I to the fourth, an I to the fourth, and then another I squared, which would be just a 1 times a 1 times that I squared, which is -1. So whenever your exponent is 2 more than a multiple of 4, we always get just -1. And then if we look at the next column, we get an I cubed times an I to the fourth. Well, I to the fourth, once again, is just 1. Then we get I cubed, and well, we know I cubed is just -I. Or I to the 11th would be an I to the fourth, an I to the fourth times an I cubed, which would be a 1 times a 1 times an I cubed, which we know is just -I. So whenever you are 3 more than a multiple of 4, you always just get -I. Now, when we're I to the 8th, that's an I to the 4th times an I to the 4th, which would be 1 times 1, which is 1. Or an I to the 4th times an I to the 4th times an I to the 4th is also 1. So whenever you are a multiple of 4 for your exponent, it's always 1. So when you're dealing with i's to different powers, you can use this pattern to simplify these down. When you're dealing with negatives inside of square roots, remember you must always first deal with that negative and then simplify your roots or multiply your roots and so on. And so this is the square root of a negative 1 times a 6 squared. So this negative right here is really a negative 1. And then your 36 is really that 6 squared. And so because it's multiplication here, you can apply the square root to each part. And the square root of that negative 1, we know from what we just talked about, is I. And then the square root of 6 squared is just a 6. Now, typically, we're going to just write this as a 6 and put the I afterwards. Doesn't really make a difference. Now, when we look over here, we're going to have the square root. We have the square root of a negative, so that's a negative 1, times, if we do a factor tree on 24, that would be a 2 squared, and then another 6. We cannot multiply these together until we've dealt with our negatives in the roots. When we go ahead and take a look at this, that would be the square root of a negative 1, and then a 2 squared, and then another 2. Since I have a square root, I want to try to write things as powers of the second power. So now, when we're looking here at the red, the square root of that negative 1 we know is I. The square root of 2 squared we know is 2, and we'd still have the square root of 6. When we're looking at the blue, we'd have the square root of negative 1, which is an I, the square root of 2 squared, which is a 2, and then this square root of 2 would still be left. So now we're dealing with all multiplication, so I'm going to multiply just like we've done in the past what's in front of my i's, or roots together. So I'm going to multiply this. The 2 times the 2 is 4. I times I is I squared. And then I'd have multiply together what's in my roots together, and that would be the square root of 12. Now, when I'm looking in front here, that's I squared we know from the last slide is a negative 1. Then I'm looking at 12, and I can simplify that just like I've done in the past. That's a 2 squared times a 3. Well, now we can go ahead and simplify that. I have the square root of a 2 squared. And by the way, 4 times negative 1 is a negative 4. And then I'll take that 2 squared, the square root of 2 squared is a 2, and I'd still have a root 3. So if I multiply what's out in front, I get a negative 8 still with my root 3. So you need to simplify what's inside your roots first before you do anything. Now, when we're looking down here at problem 11, we need to look at the powers of I from the last slide. And 34 is 2 more than a multiple of 4, because a multiple of 4 would be 32. And I'm 2 more than that, and to get to 34. And so on my last slide, if you're 2 more than a multiple of 4, it's always going to be negative 1. So this just simplifies down to negative 1. When I'm looking over here, 83 is really an 80, which is a multiple of 4, plus 3 more. So I'm 3 more than a multiple of 4. On my last slide, 3 more than a multiple of 4 is always negative I. So I just get negative I. So you can use that pattern from the last slide to simplify any i's to different powers. Well, here we're just adding And remember, when you're adding, we don't really need the parentheses, so I'll just write down what we have. And then remember, you can multiply or add in any order you want. So all I'm going to do is combine together my like terms, those that don't have i's. A 9 plus 8 is 17. And then I'm going to go ahead and deal with my like terms of the i's. Negative 6 of the i's plus 9 of the i's is plus 3 of the i's. Over here on the right, we are subtracting, so then we can go ahead and distribute that through, and then we can write it without any parentheses, and so then we get plus 9 minus I, and then we can combine together like terms. Our normal number is 10 plus 9 is a minus 1. And then I can go ahead and negative 1 of the i's plus negative 1 of the i's is negative 2 of the i's. Down here, all we have to do is just distribute into here. 7i times 2 would be 14 of the i's, plus 7i times 3i would be 21 of the I squared, because I times I is I squared. Oh! Remember, I squared from our first slide is really a negative 1. And so we really have a 14i plus a 21 times negative 1. Well, typically it's written in this form here, a part that doesn't have i's followed by something that does have an I. So I'm going to take this negative 21 and put it here, and then I'm going to go ahead and write this, which is plus 14i. Over here, we have two things that we're adding, and then we're squaring it. Well, remember, squaring means multiplying it by itself. So I'm going to go 3 plus 3i times another 3 plus 3i. And then all I have to do is just double distribute or FOIL. So 9 or 3 times 3 is 9. 3 times this would be 9 of the i's. And then I do this times this, which is also 9 of the i's. And then I do this times this, which is 9 of the I squareds. Now I can go ahead and do a little bit of simplifying. I have like terms, 9 of the i's plus 9 of the i's is 18 of the i's. And then we go ahead and we look at this. Remember, I squared is negative 1, and a negative 1 times 9 is negative 9. So then I have like terms. I can put my 9's together, which is 0, and then I would still have my 18i. Well, 0 plus anything doesn't change it, so it's just an 18i. Now, looking here, remember that I represents a square root of negative 1. And so this is like having the square root of a negative 1 in the bottom. Remember, we don't like to leave roots in the bottom. So we got to get that root or any of the i's out of the bottom. So I'm going to multiply the top and the bottom just by an I. Because when I take this I times this I get an I squared. Well, I'd still also have that 8 there. And then all I have to do on top is distribute this I into both. Well, negative 3 times I, and then negative 5i times the other I would be in minus 5i squared. Now, remember from earlier that I squared is negative 1. So when we look at the bottom, that green I squared is a negative 1 times that 8 is a negative 8. Also on top, that red I squared is a negative 1 times that negative 5 was really plus 5. And then I'd have that negative 3i. So for our final answer, we're going to write 5 minus 3i over 8 if you wanted, over negative 8, if you wanted, you could bring that negative up to the top and distribute through, and you get negative 5 plus 3I over an 8. Either one of these answers would be acceptable. My preference would be for the bottom one, but the top one would also work. So over here in 53, remember that our I is the square root of negative 1, so we can't leave it down there. Now, we do have two terms here. Remember when we were dealing with roots before and we had two terms in the bottom, that's where we had to do the conjugate. So I'm going to go 8 plus 2I, switching the sign in between. And if I do that on the bottom, I have to do that on the top. So on the top, we just have a 2 times 2 terms, so I can distribute that in. So that's a 16 plus 4I. On the bottom, I have 2 terms times 2 terms, and so I can just double distribute. 8 times 8, 64, plus 8 times 2I is 16I. And then I can go ahead and take my negative 2I, which is negative 16I, times the 8, which is negative 2I times 8, it's negative 16I. Negative 2I times positive 2I is a negative 4, and then an I squared. So then we have like terms. These are going to cancel each other out. We also have this I squared here. Remember, I squared's negative 1. And so when we look at the bottom, we get this, that I squared's negative 1. And so then negative 1 here times our negative 4 is really plus 4. And we no longer have i's in the bottom. And that's our preference, is not to leave it with i's in the bottom. And so we end up getting a 68 in the bottom. And then the top is a 16 plus a 4i. And we can go ahead and simplify this because everything is even. Okay, so I'm going to take I can pull a 4 out of the top, but I can't pull a 4 out of the bottom. I'm going to just pull a 2 out of the top. Pull a 2 out of the bottom. Now, when you have 2 times the whole top and 2 times the whole bottom, you can cross out the 2's. And then you can look at what's left. And we're just left with an 8 plus 2i over a 39.